Today we'll be looking at Lesson 2.9, which is titled Weighted Averages. But the idea of this lesson is to present a few different ways of solving different types of word problems. So what you would like to do, or what I would like you to do first, is to determine what kind of problem it is, and then there's a way to solve that particular problem by setting up a diagram. So we'll look at a few different problems, and then on your own, when you do the classwork, you're going to be determining what type of problem that you need to solve and then how it's solved based on these examples. So the first one is considered how many pounds of premium coffee beans should be mixed with 2 pounds of supreme coffee to make the blend coffee. So this is considered to be a mixture problem. Okay, so the mixture problem, there's an example in the textbook also on this, but this is an example of a mixture problem. As you can see, it says the word mix in it. That kind of is a key word. But with a mixture problem, you want to determine, first off, the three types that you're going to be mixing, which we have here in the table as premium, supreme, and blend. Okay, so that would be your first column. Then you have another column, and this is always going to be the same type of setup, where you're going to put the number of units. Okay, so there is 2 pounds of supreme that we know of, but then we don't know how many pounds of premium. And then the blend is going to be the combination of the premium and the supreme, so that's why that's x plus 2. And then we're going to put the price per unit, and they give this to us in the beginning, so it was $9.50 per pound for the premium, $11.75 per pound for the supreme, and $10 per pound for the blend. So I listed that in the third column. And then the fourth column is how you would get your total price. So price per unit means you're going to multiply the price times the number of units. So you would do $9.50 times X for the premium, and $2 pounds times $11.75 for the supreme, and then 10 times X plus 2 for the total price of the blend. And then what you're trying to solve for is X here. So I'm going to take my last column, and since I'm combining the premium plus the supreme to equal the blend, I'm going to write it like this. $9.50 X plus 2 times $11.75 equals 10X plus 2. So I'm going to solve, so I need to multiply 2 times $11.75, which is $23.50, plus $9.50X. I can't combine those because one has a variable and one does not. I can distribute the 10 to the x and the 10 to the 2 to get 10x plus 20. And now I need to combine the like terms across the equal sign. So I'm going to take the 950x and let's say I'm going to bring that over to be with the 10x by subtracting it. So that cancels it out on the left side. And my right side I now have, I'll rewrite, I have $23.50 on the left side equals 10x minus 9.5x gives me just 0.5x plus 20 on the right side. And I still need to combine the 20 and the 23.50, so I'm going to bring the 20 to be with the 23.50. And I get $3.50 equals 0.5x. And to get x by itself, then I would have to divide by 0.5. I ran out of room here. So 350 divided by 0.5 gives me 7. Now, another problem that you might come across is particularly when you have percents and mixtures of things. So in this case, we have percentages of antifreeze or certain types of antifreeze that we're going to mix together to get another percentage of that type of antifreeze. So this has, again, another setup with a table. So we're given that we have 40% glycol antifreeze and we have 60% glycol antifreeze, and we need to know how much of each percentage of glycol antifreeze should I mix together to get 48% glycol antifreeze. So here's my table. I have all my percentages listed on the left as the first column. And then I have the amount of antifreeze listed on the the next column. So notice that I put X for the 40% and Y for the 60% because they're different percentages. And then they told me how much 48% glycol antifreeze that I need, which is 100. So I put that as 100. Then I have the amount of glycol antifreeze, which would be the percentage times the amount, basically. So 0.4, I just wrote 40% as a decimal, so 0.4x. And then 60% I wrote as a decimal, 0.6 times y. And then I also multiplied 0.48 times 100 for my last column. And this is actually a little bit advanced for us because we haven't quite talked about solving equations with two variables or sets of equations, but I'm going to show you here what you would do. So my first equation, look at it. It has the percentages, so I have just 0.4x plus 0.6y equals 48. That's my last column in the previous example, if you want to look here. Okay, that is this column. And then my second equation comes from this column. So it's just x plus y equals 100 right here. So what I need to do to solve is I'm going to choose the easiest method here. There's certain methods that we'll learn later on, but this one is called elimination. And what I need to do is I need to eliminate one particular variable first. Okay, so I chose to eliminate the x's. Now to do that, I'm going to need to have the x's be the same value. So that's why I multiplied my second equation, all of it, by 0.4, so that I have both x's with a 0.4 in front of it. So now my new equation is 0.4x plus 0.4y equals 40. And what I'm going to do to eliminate is I need to figure out whether, if I have 0.4x and 0.4x, do I need to subtract to get 0 or do I need to add them to get 0? Well, in this case, I need to subtract. Okay, so I'm going to take 0.4x minus 0.4x, and what that does is it eliminates the x. And then I'm going to take the same thing and line up my y's, and I'm going to take 0.6y minus 0.4y, which gives me 0.2y. And then I'm also I have to put the equal sign in between, but then I have 48 minus 40, which gives me 8. And so I solve for y by just dividing by 0.2 on both sides. I get y equals 40. Now to get the x, what I did with the x is I plugged it back into my original equation, this one, this equation in parentheses. I plugged in y equals 40, and then I solved for x after I was done. So I got x equals 60 and y equals 40. So that means that to get the 48% mixture like it wanted us to, that I need 60 gallons of 40% glycol, because that represented our x, and I need 40 gallons of 60% glycol, because that represented my y. The next problem is called, well, it's particularly speed, finding the speed of something, but it's a weighted average problem. And that's because we have more than one average here that we need to find, and we need to combine to get a total average speed. So in this case, we have Austin jogged 2.5 miles in 16 minutes and then walked 1 mile in 10 minutes. So we need the combination of his average speed. And in this particular problem, what you need to use is a popular formula. I call it DIRT, which it represents distance equals rate times time. So distance is d equals rate times time. And whenever you're using a speed problem or solving a speed problem, you always want to use some form of this formula to use. So I've rewrote it to be equal to r, which is what we practiced in the last lesson for 2/8, because I'm trying to find the rate, or the speed is a rate. So I put it equal to r, and then where I got the numbers from, I have 2.5 as my numerator, and if we go back, it says Austin jogged 2.5 miles, so my numerator is going to be the distance, and then in 16 minutes. But I wrote 16 minutes as hours, okay? So that's where my denominator comes from. It's time, but I'm writing it in terms of hours. So what I did is I took 16 out of 60, and that gave me my 0.27. And then if I divided, I get 9.26. Then I need to find my other rate for when he walked 10 minutes. For 10 minutes and he walked 1 mile. So I put 1 mile on the top, which is the distance. And then I found 10 minutes in terms of hours, so 10 over 60, which gave me about 0.17. And again, I divided, and I got 5.88. Now, that is not my answer yet, because I have two separate rates. Here's where the weighted average comes into play. I found my two rates, and if I move to the next slide, I have my two rates included. Okay, notice I have 9.26 there, but then I multiplied it by the minutes in terms of hours, so that's where the 0.27 comes into play. Then I have my other rate, 5.88, and then again I multiplied it by the hours in terms of, or the minutes in terms of hours, which was the 0.17. And then I'm going to put that over both hours, or both times, okay? So if I multiply everything out, okay, I would get 9.26 times 0.27 which is 2.5 plus 5.88 times 0.17. I'm just following order of operations here, which is about 1. It's 0.9996, so I rounded it to about 1. And that's going to be over 0.27 plus 0.17, which is 0.44. So I get 2.5 plus 1 is 3.5 over 0.44. So my final answer is about 7.9, which I would say is about 8. So the average speed that he was going was 8 miles. Per hour. And then our final problem is going to be speed also, so we're going to use DIRT as our formula, but we're doing the speed of two vehicles. So we need to look at both vehicles in our table, and I used a diagram here. It says, well, first let's read it. It says, two cyclists begin traveling in opposite directions on a circular bike trail that is 5 miles long. Okay, so they're 5 miles apart when they start. Then you have one cyclist travels 12 miles per hour and the other travels 18 miles per hour. How long will it be before they meet? Okay, so they're going in opposite directions but on a circular path, so they will meet. So what we do is set up our table with cyclist 1's information and cyclist 2's information. Using the formula D equals RT, we know that the rate is 12. Okay, that comes from the fact that you have 12 miles per hour. Okay, remember rate was speed. Then you have 18 for cyclist 2. We do not know the time, so that's why we put both of these as just a T. And since they're both time, they can both be T. They don't have to be different variables. And then to find my distance, I'm going to need to multiply my rate times my time. So 12T is what I get. And then 18T. Since this is a combination of two cyclists, I'm going to need to set up an equation where I have both cyclists equal to the distance that they are apart. So 12T plus 18T is going to be equal to 5. Now I solve for T by dividing, well, first off adding 12T plus 18T together, 30T, equals 5. And then I divide both sides by 30 to cancel out everything with the T. So T would be 1/6. If you think about 1/6 of an hour, you would probably want to write it more in minutes to make more sense, because we don't usually say 1/6 of an hour. So if you break up 60 into sixths, there's 6 of them, so that would give you 10 minutes would be the most reasonable answer there. And that concludes our lesson. Now, if you're watching this, what I want you to do is to make sure you've included each type of example problem on your notes and what type it is. And what I will do is I will let you use 2-9 notes on the quiz. Because what it will help you understand is how to set up a particular problem. The only thing you'll need to know is what problem it is, and then you can pick the setup based on the 4 examples that I gave you today. You won't have any different examples than that. So you'll be able to use 2-9 notes on the quiz. All right.